Okay, so hopefully you just finished the penny investigation or watching me do the penny investigation. And what Cavaliers Principle says is that as long as your two shapes, be them slanty or be straight up, be them what we call right, as long as they have the same height and the same area at each horizontal cross section, then they're going to have the same volume. And this is named after our friend Cavalieri, the Italian mathematician. So, alright, so let's look at some slanty shapes and just make sure that we know what to do with those. So, the volume of this slanty oblique prism, we know the formula is area of the base times height. In this case, again, our base is the 13 by 20, and also the top is considered a base. So that's going to be 13 times 20. And I hope by now that feels comfortable to you that the height is that 10, even though it's outside the prism. So 13 times 20 times 10 gives us 2,600 yards cubed. Okay, same thing with the cylinder. Slightly different formula, more or less the same formula because it's still area of the base times height, right? So we have pi times, in this case our radius is 8 squared. Our height, our distance between our circles is 30. So when I plug that in my calculator, pi times 8 squared times 30, that comes out to approximately 6,031.9 centimeters cubed. Okay. Alright, so the next thing is what happens when I put shapes together? What if I combine two prisms or combine a cylinder and a prism? So let's look at, find the volume of each composite figure. All of these that we're going to do in this class will be add strategy. So what I have in this first picture is basically two prisms. I have this yellow prism and I have the green prism, and we want to add together their volumes. So we're going to find the volume of the green prism and the yellow prism and add them together. So for both of those, the volume formula is area of the base times height. So the area of the base, we have 2, and then we have 4. Be careful not to use the 6. The 6 is all the way across, including part of that yellow prism. So we have 2 times 4 for the area of the base, times my height is that 8 over there, the distance between the top and the bottom. Okay. Then for the yellow prism, we've got area of the base times height, so that's going to be 2 again, from front to back is still 2, and then this right here we know is 2 also because 6 minus the 4 we already used up for the green prism leaves us with 2 for the yellow, so 2 times 2 for the base, and then our height on this guy is 3. Okay, so we have 64 for the green prism, we've got 12 for the yellow prism, we add those together and we get 76 feet cubed. Okay, let's take a look at part B. On this one, this is supposed to be, it's a little bit tricky, this is supposed to be a half cylinder. That is not a half sphere, it's a half cylinder is what that's supposed to be, and then a prism combined with that. Okay, so let's start with the prism. So that's volume, area of the base times height. So we're talking about 11 times 6 would be the area of our base times our height, our distance between our top and our bottom base, right, is going to be that 12. Okay, and then we're going to go find the half cylinder. So, not sure if I can draw a half cylinder. That was terrible. Okay, so, but if a whole cylinder is pi r squared h, then a half cylinder is going to be 1/2 pi r squared h. So this is going to be 1/2 pi r squared. Let's see. We've got a couple of different ways we could think about this. One is that we have 15 going all the way across, and 11 is just part of that distance, so 15 minus 11 would be 4. It does also appear that this height is 12, which should have been that the radius was 6. So this is apparently a bad problem because those numbers don't correspond. I'm going to go with the 4 for the radius, but if you use 6, that would be okay too. Your distance between the circle bases, we're talking about the front and the back, or the circles, is going to be a distance of 6. And so if we put all of this in our calculator, okay, we get 792 for the prism. We get 150.796 for the half cylinder. And we're going to add those together to get 942.8 inches cubed. So we added together the 792 and the cylinders, the 150 amount. Okay. There's one more problem. It's a you try. Why don't we'll pause the video and give it a shot and we'll see how you do. Okay, so there were a couple of different ways to work this problem. I drew in my vertical line right here to split that yellow prism and the green prism. If you could have drawn a line right here, that would have also have gotten you the same result. Your work will just look a little different. So, let's start with the yellow one. The area of the base, well, it looks like, let's see, this is 4 and this is 4. The distance from front to back, it looks like, is 12. So the area of that rectangle on the bottom is going to be the 12 times the 4. And then it looks like my height of that prism is 9. On the green one, it's a little bit easier to see what's going on. Be careful, it's tempting to say 16 times 12, but it's actually 16. Take away this 4 that we used up on the yellow prism. So that's what, 12 is left here. 16 minus 4, so that's going to be 12 times the height of 5. Okay, so let's put that in our calculator. I'm getting 720 for the green prism, and it's 432 for the yellow prism, and we add those together, and we get 1,152 meters cubed. Okay, so what I would ask you to do now is go ahead and complete the Math Excel on volume of prisms and cylinders, and then you'll be ready for your next note packet.